Good morning, students. Today we are going to discuss about calculation of inductance and capacitance of double circuit three-phase bundled conductor. The circuit shown here is the example of three-phase circuit which is having the bundled conductor and it is a double circuit. Double circuit is nothing but it is having the go conductor and return conductor separately. Okay. So for this problem, we are going to discuss about the calculation of inductance and capacitance, as well as we are going to verify the results using MATLAB also. So in this circuit, we are having three-phase transposed line composed of two ACSR, aluminum conductor, steel reinforced. Okay, so this is a C mill, is nothing but circular mill, which is the unit for area of cross section of the wire. Okay, 45/7, which is nothing but 45 aluminum stranding conductors it is having, and 7 steel stranding conductors it is having. Okay, so below the details are given, that is 1.427 diameter. It is specified in inches, correct? We have to convert this into meter, and then spacing between the bundle, that is the spacing between these two conductors, is 18 inch. We are going to find out inductance and capacitance of these lines, and we are going to justify using MATLAB also. Okay, here in A phase we have go conductor as well as return conductor. A dash rendu சேர்ந்து A phase, B dash together constitute B phase, C dash together it's a C phase. Okay, now see, for our comfortability, no, we take this as a single conductor instead of bundle conductor. No, I'll take this as a single. Okay, to calculate the distance between the conductors. So this as a single, and then this as a single. For our comfortability, I am changing this. Okay, I am considering this as a single conductor, which is a bundled conductor. Remember that one. Okay, now I rewrite the name of this conductor as A1 A2 B1 B2 C1 C2. For this problem, the given data is diameter 1.427 inches. So we know 1 inch is equal to 2.54 centimeter and 1 centimeter is equal to 0.01 meter. Our aim is to find out all the parameters in meters. Okay. So now the 1.427 multiplied by 2.54 multiplied by 0.01, we get 0.0362 meter. And then radius is diameter divided by 2, hence you will get this one, 0.0181 meter. Bundle spacing is given in the problem as 18 inches. So again the inches is converted into centimeter by multiplying 2.54, and centimeter is to meter conversion is multiplication with 0.01. So we have now two datas, one is radius, another one is bundle spacing. Our aim is to find out inductance as well as capacitance. First let us find out inductance, correct? We know the formula to find inductance. L is equal to, actual formula is 2 into 10 power minus 7 ln of GMD divided by GMR for the inductance, correct? So GMD is geometrical mean distance, GMR is geometrical mean radius. This is also called as self GMD, correct? For GMR for inductance as well as capacitance calculation is different. Okay, so now this is actually the unit of this one is meter, Henry per meter, Henry per meter. Now I am going to convert this into millihenry per kilometer. Okay, this is our requirement. So that what I have to do, no, to convert Henry to millihenry, I have to multiply it by 10 power 3, correct? The answer is to be multiplied by 10 power 3. And then for meter to kilometer conversion, I need 10 power minus 3, correct? If the 10 power minus 3 goes up, it becomes 10 power 6. So I'll get the same answer. L is equal to 2 into 10 power minus 7 ln of GMD divided by GMRL multiplied by 10 power plus 6. See here, 10 power minus 3 goes up, means 10 power plus 3. This is unit is millihenry per kilometer. So if I multiply this, I'll get 2 into 10 power minus 1. So the 2 into 10 power minus 1 only, 2 into 10 power minus 1. This is written as 0.2, correct? So my final formula is L is equal to 0.2 ln of GMD divided by GMR base L, that is for inductance, millihenry per kilometer, correct? This formula only we are going to use in MATLAB. Okay, so what is GMD? Geometrical mean distance. Okay, so GMD is equal to distance between the face AB and distance between the face BC, distance between the face AC, correct? So as we have the three distances, the geometrical mean, no, so you will get power 1 by 3. So this only is written as cubic root, correct? It can be written as DAB dot cubic root of DAB, DBC, DAC, correct? So in MATLAB we are going to use power 1 by 3. Hence I use the same format. Okay, so DAB, okay, A is one face, B is another face, C is another face, correct? I already told A consists of A1 and A2, go conductor and return conductor. Similarly, B consists of B1, B2. C is having that is called double circuit, correct? C is having the go conductor and return conductor. Now DAB, no, distance between A and B can be written as, that is mutual distance between the face A and B. So A1 to B1, distance between A1 to B2, like that I have tried. Okay, distance between conductor A1 and B1. Similarly, see here, this one and this, clear? So then distance between A1, B2. Similarly, the another conductor from A face, DA to B1 dot DA to B2. Now I have the 4 distances, hence the power is 1 by 4, clear? Similarly, I have to write DBC, that is the distance between the face B and C. Face B is having 2 conductor like A face, C is having 2 conductor like A face. So now I have to find out the distance between B1, B2 and C1, C2. So again I'll get, see, distance between B1 and C1, distance between B1 and C2. Similarly for B to C1, B to C2. So I'll write this one as B1 C1 dot DB1 C2. Again D B2 C1 dot D B2 C2. See here, B1 C1 and B2 C2. So this is a B phase consists of 2 conductors. Hence we will have 4 distances. As we have the 4 distances, we will get the power as 1 by 4, correct? Similarly, DAC. DAC, same manner, A to C. So I have to consider first A1 conductor, distance between A1 and C1, C2. Similarly, the another distance are between A2 and C1, C2. So I can write this as A1 C1 dot A1 C2, correct? Dot DA2 C1 dot DA2 C2. As I have 4 distances, I will get power 1 by 4. Now as per the formula, see, GMR, self GMD for inductance is calculated, correct? So I can write formula for GMR as GMRL, correct? GMR is also called as self GMD. Okay, so how many phases we have? 3 phases. So self GMD of phase A we have to find out, and then self GMD of phase B, self GMD of phase C, correct? Now we got the 4 distances, clear? Hence I can put this as power 1 by 3. Still we have to find out DSA, DSB and DSC. If it is having a single conductor, no problem, we will directly write that one. Okay, now see here we have the DSA. So go conductor and return conductor having the bundles of conductors, correct? So I have to write like this: self GMD of the bundle conductor. Sometimes it will be given in the problem, or sometimes you have to find it out. In this problem we have to find it out. It is not given, correct? DSB dot it's for A phase, correct? So distance between the conductor A1 and A2. So this is the formula. This, as we have the two distances, we have the square root. The another way we can write this as ds dA1 A2 power 1 by 2, correct? Similarly, I can write for the another phases DSB. DSB is self GMD of the bundled conductor dot D B1 B2. Distance between the conductor B1 and B2, it's a two distances, hence I will put 1 by 2. Self GMD. D means self GMD, which is geometrical mean radius. Okay. Then similarly, DSC is equal to DSB dot D C1 C2 whole power 1 by 2. Clear? We can put even square root also, correct? So to write in MATLAB, either I can put the coding as SQRT or power 1 by 2. Both are same only. Okay. Then from the problem we have to find out DSB, GMR of bundled conductor, which is nothing but square root of ds multiplied by d. We know for inductance, self GMD, that is geometrical mean radius, GMR, is nothing but R dash, which is nothing but 0.7788 multiplied by R, correct? So we know the radius, d is the distance between the bundled conductor. Everything is given here, correct? So we have to just substitute. So ds value is 0.7788 into R multiplied by distance between the bundled conductor. We have already found it this as 0.4572, correct? So just substitute here 0.7788 into a radius value 0.0181 multiplied by this is distance between the bundled conductor. Okay, so 0.4572. So simplifying this, we'll get DSB as 0.08. Now this is a given diagram, correct? I have considered a single conductor, like to find out the distance between the conductors, correct, which is useful for our formula. So now I'm going to calculate first for distance between A1 B1, correct? For that one I am making a triangle like this. See, the height is 7 meter and I have to calculate this distance, correct? I have to calculate the distance. Now 11 meter. So if 11 meter will be in this side, the pending of the lengthy line is 16.5. The pending is 5.5, correct? So I have to find out half of the value which is available in the both side. See here, from this 16.5, correct, the entire length of the line minus 11 is 5.5 divided by 2. Both side we have to give the space, correct? So divided by 2 will get 2.75. Okay, so I'll get here at this point, correct, 2.75. the height is 7. Okay, so the distance between A1 B1 I can find it out. Okay, same manner here also I am having the 2.75 meter and here also 7 meter. So this also form a right angle triangle. Hence I can write here as dA1 B1 is equal to, correct, distance between DC2 B2. Okay, which is equal, both are the same right angle triangle, so which is equal to square root of, this is a hypotenuse, correct? Distance between A1 B1 is a hypotenuse, so I can write a 7 square plus 2.75 the whole square. So its value is see 7.521. So 7.521 meter. Okay. Now A1 to A2, for example, A1 to A2, let me calculate A1 to A2, distance between A1 to A2. How will you find out this one? So see here, from here, correct, I can make it as a right angle triangle. Okay, So what is the length here that we know? Till this it is 11 meter. So I have to calculate this length also. What is the length? So entire length is of this line is 12.5. So if till this it is 11 meter, exactly parallel, correct? Exactly parallel to the line 11 meter. So 12.5. So I'll get 12.5 minus 11. Remaining is 1.5. Both side I have to leave. So divided by 2, I'll get 0.75. So this distance is 0.75. So till this it is 11 meter. Correct? Till this it is 11. So this distance is 0.75. Now I am getting a right angle triangle with the base 11 plus 0.75, which is nothing but 11.75 is the base. Correct? And then the height is 7 plus 6.5, which is nothing but 13.5 altitude. So now see, I got the altitude, I got the base value as 11.75. Now the hypotenuse value will be the distance between A1 and A2. Similarly, see here the distance between C1 and C2. So this forms a right angle triangle. See here, till this it is 11. This distance is 0.75. Again the same calculation. So shall I put dA1A2 is equal to distance between C1 and C2, which is the square root of the base value is 11.75 the whole square plus altitude is 13.5 the square. Okay. See, I am getting 17.897. 17.897 meter. Okay. Similarly, I have found out A1, B1, B1, which is same manner I am going to find out this side. Correct? So distance between B1 and C1. Distance between, I am going to find out distance between B1 and C1. And the entire length of this one is 12.5. Correct? So I have to get the distance from here to here. Clear? The entire is 12.5. This line is 16.5. So 16.5 minus 12.5. Value is 4. So in both sides I have to leave. So 2 meter. So this length is 2 meter. And then same manner, this distance is 2 meter. So both triangle are same. So now see here, B1 C1 is equal to D A2 B2 or B2 A2. We can give in any manner. Okay. So what I'll get, square root of, okay, the base is 2. So 2 square plus the altitude is 6.5. 6.5 whole square. It's equal to, so 6.801. Then same manner we have to find out the distance between A1 B2. Correct? Similarly, C2 B1. So how will you find out this? A1 B2, the altitude is 7 and the entire base. So from this point, this length is 2.75, this length is 2.75. Correct? I need from here to here. So till this it is 11 plus 2.75, 13.75. Correct? So I need this till this to this. Correct? Till this it is 11. Correct? 11 plus 2.75 distance, 13.75, altitude is 7. So now I can write D A1 B2. Okay. What is another triangle? Before that I will put that answer. Okay. 7 square plus 13.75 the whole square. So I have completed A1 B2. Okay. So the same triangle is formed here, this side also, C to B1. So which is equal to C to B1 or B1 C2. Okay, both are same only. See here, same 11 plus 2.75, 13.75, and then the altitude is 7. Okay, 15.43. Okay. Same manner we will calculate the distance between B to C1. So B to C1 means this is the triangle, we get it. Okay, this is a triangle. So the altitude is 6.5. From here to till this we have to find it. Okay, it is already till this length, it is already 12.5. The pending is 2, so we'll get it this as 14.5, correct? So from this point to here, so 14.5 is the base. See here, D, C1, B2, like this. So suppose if you feel difficulty here, you can draw like this also, you'll get like this, correct? So till this it is 12.5. After that we'll get 2 here. This is 6.5. So DC1B2, same manner DC1B2 will have the distance between A to B1, correct? So which is equal to D A to B1 is equal to square root of 14.5 the whole square plus 6.5 the whole square. So I'll get 15.89. So we have almost calculated all the distances except B1, B2, correct? So they are in the straight line. So distance between D, B1, B2 is equal to 16.5 meter. The calculation of distance between these conductors only different. Now just we have to substitute all the values in the formula. That's it, we'll get the answer. Okay. So once again I show you the formula. DAB is geometrical mean distance of these 4 distances, correct? Then DBC is 4 distance multiplied by power 1 by 4, correct? DAC, these 4 distance, and GM or L we have going to calculate this also. Okay, substitute all the values in this formula so that we will get DAB, DBC, DAC. We need to find out one more distance also, A1, C1, correct? Distance between A1, C1, which is equal to distance between A to C2, correct? So which is equal to A to C2 is equal to, see here, the distance till this it is 11 meter, correct? So both side we are having 0.75, the distance which is already we have calculated 0.75. The altitude is 13.5. So base is 0.75. So we can able to again form a right angle triangle, correct? So by Pythagoras theorem we will again can form 0.75 whole square plus 13.5 the whole square, correct? So its value is 13.52. See here we have just substituted DAB. This is a formula. I just substituted all the values, distance calculated. So I'll get 10.582. Similarly for DBC, this is a formula. I substituted all the values which we have already calculated. I'll get 10.582. For DAC, A1 C1 is calculated which is equal to A1 C2, correct? A2 C1 and A2 C2 can be directly calculated from the diagram. See here, this is your diagram. So distance between A1 C2 is 11 meter. Distance between A2 C1 is 12.5. So the answer is 12.59 for DAC. Now geometrical mean distances, we know the formula DAB dot DBC dot DAC power 1 by 3, correct? Just substituted all the values here. Now GMD is 11.21. Similarly, I have to find out GMR for inductance, correct? Self GMD of phase A, phase B, phase C, power 1 by 3. So for phase A, self GMD of phase A, this is the formula. So I just substituted the values for this formula. I have to get the values for this one. So these are the values of self GMD of phase A, B and C. Now GMRL value is 1.181, correct, based on this formula. We got GMD as well as GMR for inductance. We know the formula for inductance, L is equal to 0.2 into ln of GMD divided by GMR for inductance, correct? We'll get answer for this. Now see, just substituting will get the final answer as 0.45, right? So the answer is now 0.45 inductance value is millihenry per kilometer. Okay. So similarly we have to calculate for capacitance. Now we are going to calculate the capacitance. Formula for capacitance is 0.0556 divided by ln of GMD by GMR for capacitance. The suffix C for capacitance, because the self GMD for inductance as well as capacitance will be different. Hence we put suffix as C here to calculate for capacitance. Okay. Now the capacitance value will be microfarad per kilometer. Okay. Now GMD has been already calculated. The same problem only we are using. So for inductance calculation we have already calculated the GMD. So the same value is taken. Then GMR for the capacitor is self GMD of the phase A, phase B, phase C. For phase A, no, so we can take this as phase A for phase B and phase C. So for phase A, self GMD of the bundled conductor multiplied by the distance between the same conductor, that is go and return conductor in the same phase, correct? Same phase. A1, A2 represents same phase. Okay. Then RB, that is okay, RB DSB dot distance between the conductors in the same phase, correct? B1, B2. Same manner for RC DSB. This is nothing but self GMR of or self GMD of bundled conductor, correct? So we have to find out the value of DSB like in inductance, but in capacitance there is small difference. There we will get R dash, which is equal to 0.7788 R. No, here only for capacitance we will get only radius. So radius already we have found out, and distance between the bundles are also already we found out. Just substitute that, we will get DSB equal to 0.09. Clear? Then here I have to substitute 0.09 multiplied by distance between A1 and A2. So substituting all the values of this A1, A2 and B1, B2, we'll get the answer 1.269, 1.219 and 1.269. So GMRC will get this as 1.252. Okay, now we can substitute in the capacitance formula. C is equal to 0.0556 divided by ln of GMD value is 11.21 divided by GMRC is 1.252. 1.252. So the answer is 0.02536 microfarad per kilometer. So we can write this as C is equal to 0.02536 microfarad per kilometer. Okay. So this is the final answer. So we can verify this answer using MATLAB also in the next video. Thank you all.